Hello and welcome to the channel. In this video, we'll be looking at a new model called as Zamba 2 2.7 billion parameter model. It's a hybrid model composed of state space and transformer blocks, and that is why I'm quite keen to see how it performs and how its architecture looks like. So we will not only be installing it locally, but we will also have a look at its architecture, what exactly is meant by a hybrid model and what it looks like. So this model follows the Zamba architecture, which consists of a Mamba backbone alternating with shared transformer block, as you can see on your screen. And if you go a bit more into detail, what this diagram is showing you that it's a Zamba architecture. Zamba consists of a backbone of standard Mamba blocks connected to a shared attention and MLP block. This block is repeated every 6 Mamba blocks but has shared parameter, which enables Mamba to utilize more flops for increased performance at the same memory cost. The input embeddings are always concatenated with a residual stream going into the shared attention block, as this provides an additional path for the model to remember the inputs. After the block, a learned linear projection maps the output back to the residual system. In more simple words, this state of the art transformer SSM hybrid architecture model at 7 billion scale or 2 billion scale preserves the flop efficiency of SSM as well as in context learning ability of attention. New neuroscience inspired sheer attention optimization is employed here that preserves the modeling performance of independent attention blocks while saving memory. So now we know a bit about what exactly this model is all about. Let me give you a bit more information here. So, and by the way, we already have covered a Zamba model, which was Zamba 1 earlier in the year. So this is a Zamba 2. And in this Zamba 2 one, there have been two key or three, I think, improvements. First is that Mamba 1 blocks have been replaced with Mamba 2 blocks. Secondly, instead of a single shared attention block, they have utilized two shared attention blocks which are interleaved in a ABAP pattern throughout the network. And thirdly, they have applied a low rank adaptation projector to each shared MLP block, which enables them to specialize the MLPs at each invocation of the shared across depth. And LoRa enables them to add depth specialization for only a minimal increase in the total parameter count. And LoRa, as I said, is a low rank adaptation. What happens in LoRa is that you freeze the original weights of the model and you add adapters on various layers, and then you just train those minimal adapters, and then you just tailor it as per your own requirement. So it is normally used in the supervised fine tuning. Okay, now also this Zamba 2 2.7 billion parameter model which I just showed you, it uses Mistral 1 tokenizer, and it has been pre-trained on 3 trillion tokens of text and code data sourced from open web dataset including Zyda. Also in the second phase, Zamba 2 2.7 was annealed on a mixture of 100 billion high quality tokens. So training has been extensive and they have really spent some time there. Other than that, the performance, if you look at some of the benchmarks, they also look good. It achieves leading and state of the art performance among models of 3 billion, less than 3 billion parameter, and is competitive with some models of even greater size. Also, due to its unique hybrid SSM architecture, this Zamba 2 achieves extremely low inference latency and rapid generation with a significantly smaller memory footprint than comparable transformer based model, and we will check it out shortly. So I think this high performance and small inference compute and memory footprint renders it an ideal generalist model for on-device application. So let's check it out. Before I show you the installation and how we will be proceeding with it, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description, and I'm also going to give you a coupon code of 50% discount on range of GPUs. This is my Ubuntu system, and then this is my NVIDIA GPU card RTX A6000. Let me clear the screen. First up, let's create a Conda environment and we will keep our Zamba model there. Let's wait for it to activate it. And now let's start installing some of the prerequisites. First is always Torch. Let me install it. And that is all done. Now let's git clone, or in other words, basically what they have done is they have forked the transformers library and they have created their own Zamba 2 based on transformers. So let me git clone it and then cd into it, and I will drop the link to model card where you can also get this link. Shouldn't take too long, it's quite big, I have seen. Okay, so now once that's done, let's install all the prerequisites within this repo, which includes the transformers, Zamba 2 and all that stuff. Okay, so you might also get this error. When this happens, it means that you would need to install this packaging library. And for that, all you need to do is to do packaging. And then let me run the previous command again and let's wait for it. So this has installed now. Let me also install the accelerate to optimize it. This is a small library, shouldn't take too long, and that is done. Now let me install a Jupyter notebook and then we will play around with this model in the Jupyter notebook, and this is going to launch it in the browser. The notebook is launched. Let's import some of the stuff which we have installed, and plus I'm also going to download the model from Hugging Face, and this is the repo and model, and I'm putting it on my GPU, which is CUDA. If you're using Mac, that just replace it with MPS, but I haven't tested it, so I'm not sure if it is compatible with MPS or not. And you can see that the model is being downloaded, so let's wait, and you can ignore these warnings. So there are two shards of the model. I think the first shard is 5 gig, and let's see how big the second shard is. So second shard is small and model is loaded on my GPU. And now let's do the next word prediction. And remember, this is a pre-trained base model, which means that it has only been trained on a huge corpus of generic data. It hasn't been instruction tuned, and it hasn't been, of course, preference aligned. So it means that you cannot use any instruction and response sort of stuff. You cannot chat with it. All it can do is it can just predict the next token. So for example, here my prompt is a good business idea would be, and then I'm converting that text into tokens, passing it to my model. Model is just generating the next token, and then we are decoding that token into text and printing it. So let me run it. And there you go. It has printed out the response pretty rapidly, and as it is just a next token predictor, so it's a test, but quite good. Now, looks like a really good model, and I'm really keen to see how people fine tune it on various data sets, alignment ones, and the preference ones. So, should be interesting to see. I will drop the link to it in video's description. Let me know what do you think about these models. Really good to see these hybrid architecture models and different, of course, alternates of transformer. I hope that you enjoyed it. If you did, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you.